All right, today we're going to go through the last section of Chapter 8. So this is kind of a shorter chapter for us. It's only the 3 lessons long. So we're going to talk about proportionality theorems in triangles. So these are going to be pieces that are proportional based on certain characteristics within the triangle. And so it kind of goes along with our idea of similar figures in that the pieces that are made are proportional. The pieces that are made are similar to one another. And so what we start off by looking at here are just some different theorems. Now the names of these theorems are not something you're going to have to memorize, just kind of what they say. So we have this triangle proportionality theorem, which you don't need to remember that name. Basically what you need to remember is if you're given a triangle, so I've got this big overall triangle here, and within that triangle I create a line that's parallel, so that's what these little arrows mean, so parallel to the third side of the triangle. Okay, and this could work no matter how the triangle's oriented. If I've got one line passing through a triangle that's parallel to the third side, this triangle proportionality theorem is going to apply. And what it's telling us is that with these parallel lines, we're going to cut the pieces of these triangles into proportional parts. So we notice that for this left side, this parallel line cut this side up into pieces of 2 and 3. On the other side, cut it up into pieces of 6 and 9. So what this theorem is telling us is that, and this is going to be kind of a main theme throughout this section as you're going to kind of become aware here, but what they're saying is these parts here on the left get cut into the exact same proportion as these sides on the right. So I can take the top and bottom, set them up and solve, and they should be the same exact ratio. So we're saying if I take 2 over 3, that should be equal to, on the other side, 6 over 9. And we can do that by actually dividing these out or just reducing the 6 over 9. So 6 over 9 reduces to 2/3. So what's happening here is when we have this parallel line, we can take the top number over the bottom number and set it equal to top number over bottom number on the other side. Those pieces are going to be proportional. Now the thing to note here is that, like we said, it doesn't matter about the orientation of the triangle. So if I had taken this same triangle and I kind of rotated on its side here, so let's say I do something like this, where now the parallel line is going this way. So this line is parallel to this line. I've still got my 2 and my 3. I've still got my 6 and my 9. Okay? So all I've done is taken this original figure and I've just kind of rotated it around. Now what I want you to be aware of is that within this setting, within this situation, besides being able to do the pieces, the 2 to 3 versus the 6 to 9, we would top over bottom equals top over bottom. We could also do something where we talk about like left over right equals left over right. And the reason that that works is if I look at this new orientation here, I can take top over bottom equals top over bottom. So if I look at it this way, I have 6 divided by 2, which we know is 3, and then I take 9 divided by 3 and I get 3. So what this is showing me is that as I'm setting these up, all I'm looking for, or all I'm recognizing is that with these parallel lines, they create proportional parts of the triangle, which means I can take top over bottom equals top over bottom, or left over right equals left over right. And this will make a lot more sense here in a second when we go through an exact example. But that's what I kind of want you to start thinking about with these types of problems. And it's going to be the same thing throughout this entire section. Like I said, it's going to be a top over bottom equals top over bottom type of deal, or a left over right equals left over right. Now, one quick thing I do want to mention here with this type of problem is with this parallel lines, we can always talk about the parts of the figure. And so that's why we're talking about the top over bottom equals top over bottom. But the other thing to note here is that when I put this parallel line in, I actually created a second smaller triangle. And so if I look at this second smaller triangle compared to the big overall triangle, so if I look at the big overall triangle here, those two triangles are always going to be similar to each other. So if I were to look at this a little bit more closely, on the left side here, I split this side up into 2 and 3, which means the entire length would be 5. And on the other side, we split it up into 6 and 9, which would be a total length of 15. Well, so if I look at that, what should be happening here is the small triangle. So if I look at my small triangle here was 2, compared to the big triangle 5, so 2 over 5, which would be 0.4 if I plug it in my calculator, should be the same as if I take the other side, 6 over the entire length, 15. So if I take 6 over 15, and again I could plug that in my calculator, 6 divided by 15 gives me 0.4. So the other thing to notice here is that you have a small triangle similar to a bigger triangle, which is exactly what we've been talking about this entire chapter. So the sides have to be proportional to each other, 2 to 5 and 6 to 15. But in terms of the types of problems we're going to see in this section, most of the time we can focus on just the pieces, the 2 to 3 and the 6 to the 9. So what this looks like, or why we would need to know this theorem, if they were to give me a picture like this, and they were to say, okay, what's the value of x in this diagram? So they're wanting us to find what the value of x is. Well, we need to understand that because I see this line KL is parallel to this line PN, that means the parts created have to be proportional to one another. So here's where that top over bottom equals top over bottom comes into play. So I'm going to take the top 12 over the x plus 1 bottom and set it equal to the other side, which was top 9 over bottom x. So this is going to be the first thing I do is I just set that top over bottom equals top over bottom. And so if I look at that now, I can cross multiply, and we've been doing this now for the entire chapter, so 12 times x is 12x. When I go to cross multiply on the other side, I've got 9 times x plus 1. I got to make sure I do the 9 times x and the 9 times 1. So we got to be really careful here. We get 9x plus 9. Don't forget to multiply everything in these types of problems. So now I've got 12x equals 9x plus 9. I just solved my equation. So subtract 9x from both sides. We get 3x is equal to 9. And then if I divide both sides by 3, x would equal 3. Okay? And if I wanted to, just to make sure that I did this correctly, I could plug 3 back in. So 3 plus 1 would give me 4. And then 3 would just be 3. And now if I take 12 divided by 4, I get 3. 9 divided by 3 is 3. And so I see that if I divide, I get the same number both times. Okay? Now, another quick thing to note here. We chose to do top over bottom equals top over bottom. We also talked about on the last slide that we could do a left over right equals left over right because the triangle can be reoriented in any manner. And so if we did the left over right and left over right, let's look at what that would make or look like. So left over right would be 12 over 9. Left over right would be x plus 1 over x. Now if I notice, when I go to cross multiply here, I'm going to take 12 times x and get 12x. And I'm going to take 9 times all of the x plus 1, so 9x plus 9. And so now I have exactly the same expression as I had before, so this is going to solve out to give me x equals 3 either way. So when you're doing these types of problems, you can do it one of two ways. Top to bottom equals top to bottom, or left to right equals left to right. Now what I would tell you is, whichever direction makes more sense to you, stick with that direction every time. So if you always do top to bottom equals top to bottom, then never change that. The more consistent you are, the less likely you are to make a mistake when setting up these types of proportions. So that's a big thing to think about with these types of problems. Now the next type of theorem that we want to talk about is called the 3 parallel lines theorem. And again, the name isn't that important. What's important is that if I have 3 parallel lines, so this is just an extension of what we just got done talking about. So if I extend it from 2 parallel lines to a third, so now I've got AF is parallel to BE is parallel to CE, so we add that third parallel line to the mix. All of the pieces that are created are still going to be proportional to one another. So just like they were in the triangle, these 3 parallel lines are going to cut any lines they come in contact with into proportional parts. So what that means for us is that I can do a top over bottom equals top over bottom type of situation, or I can do a left over right equals left over right. So if they were to give me some information here, let's say they say AB has a length of x, FE has a length of 6, BC has a length of 10, and ED has a length of 15. So that's just the information they give us. Well, using this theorem, we can do a top over bottom equals top over bottom. So x over 6 equals 10 over 15, and then I could cross multiply and solve. Okay? Or, just like we did with the last one, we could do a left over right equals a left over right. So we could do an x over 10 is equal to a 6 over 15, and we could solve for the missing pieces. So the big thing here is, again, with 3 parallel lines, it's the same as with 2. Top over bottom equals top over bottom, or left over right equals left over right. And again, whichever direction made more sense to you, make sure you stick with that same exact direction every time. So for me personally, I always do top over bottom equals top over bottom. And again, it doesn't matter how the lines are oriented when you're working with these types of problems. Okay. So like if I were to look at the same picture, but I rotate it around. So I have this line parallel to this line, parallel to this line, and then I've got these 2 lines that are coming out here. I'm still going to take top over bottom equals top over bottom with that situation, or left over right equals left over right as we go through the setup. So that's, again, kind of the main idea, the main pattern that we see emerge within these theorems for today. So if I'm looking at this picture, it says find the length of HG. So in the picture, HG is this length right here. And so what they're telling us with these little angle markings is that this top line is parallel to this middle line is parallel to this third line. So Main Street is parallel to 2nd Street is parallel to South Main Street. So what that tells me is I can do my top over bottom. So on this left side, I've got 120 in X. So I'm going to take the top over the bottom and set it equal to, on the other side, top over bottom. So 150 over 300. And now once I have that set up, I can go ahead and cross multiply and solve. So I've got 150 times X. And then I take 300 times 120. And I get 36,000. And then if I divide both sides by 150, I get 240. And then my units would be yards. So line HG would have a length of 240 yards. And so again, that's my preference, is the top to bottom, but if it makes more sense to you to go left and right, the same thing should apply. Left to right means 100 over 150 is equal to left over right, x over 300. And if you notice, we're going to get the same expression either way. 150 times x is 150x. 300 times 120 is 36,000. And so x is still going to be 240 yards, no matter which way I set it up. So when you get these 3 parallel lines, or any set of parallel lines in a figure, you know you can always do a top to bottom equals top to bottom, or left to right equals left to right. And again, stay consistent with your setup. Figure out which one works best for you. Stay with it. The last theorem then is called the triangle angle bisector theorem. And so all this one's talking about is if you have a triangle, when they throw an angle bisector in, and this is something we've talked about in the past. So we have this angle bisector, it comes in and cuts the angle in half. We can see that with those little markings. So when you see this setup right here in a picture, so they have a line cutting through the triangle where the 2 angles are marked congruent, we're going to be using this triangle angle bisector theorem. And all this triangle angle bisector theorem says is that the parts that are created are proportional. It's exactly the same as our parallel line theorems. So what that means is I can go ahead and take the top over the bottom on the left side, match it up with the top over the bottom on the right side. So all I would do is match up top to bottom with top to bottom. 15 over 10 would be 1.5. 30 divided by 20 would be 1.5. I get the exact same proportion either way. And again, I could do it the other way, where we go left over right. So if you're a left over right person, that would be 15 over 30, which would be 1/2. And then it'd be 10 over 20, which again would be 1/2. So either way you work it out, it's going to be the same thing either way. And so just like with the other types of problems, you're going to get something that looks a lot like this. So we have our triangle, we have the angle bisector, we can see that with the angle marks there. And so what I'm going to do is I'm going to set up a top to bottom equals top to bottom. So I just got to figure out which pieces go together. So top to bottom, 13 over 5 equals top to bottom x over 23. And so when I go to cross multiply, I get 5 times x is 5x. I get 13 times 23, which is 299. And then if I divide both sides by 5, x would equal 59.8. And again, decimals are okay to get. They're not always going to come out nice and neat with these proportions. So make sure you have the top to bottom set up with top to bottom, cross multiply and solve. Or again, just for a quick reference, if we did left to right with left to right, that would be 13 over x equals 5 over 23. And when I cross multiply, I get the same thing. 5x equals 299, and so x would equal 59.8 like we saw. So any type of problem that's set up like this, if you got multiple sets of parallel lines, or if you have an angle bisector that you see like right here, you're doing a top over bottom equals top over bottom, or left over right equals left over right, and stay consistent with that. Now, with these types of problems, they're also going to ask you to do something like this. So they might ask you to set up a proportion by just filling in the blank. So what's missing based on how they set up their situation. So if I'm looking at this picture here, I see my parallel lines. So right away, that's telling me that I got proportional pieces, top to bottom, or left to right, left to right. So here, though, they're telling us specifically which pieces to match up. So they're saying take RW right here, match it up with WS. And then on the flip side of that, they want you to match up RL with, and we got to fill in the blank. So since they went from RW to WS, we want to do the same thing and go from RL to LT. And so that's what we're going to fill our blank in with, is just the missing piece. So all we got to do is figure out their pattern. And that's what's nice about these types of problems, is they're going to establish a pattern. And then we just have to apply that pattern to our problem and just make sure we follow the same exact direction. So if we look at the next example, it wants to match up RW with RS. Now RW is the piece here, and they want to match it up with all of RS, the whole side here. So then if I want to apply that same idea on the other side, it says match up what with RT? Well, RT is this whole side, so we need to know, well, what matches up with RW? So if I come across here, RW would match up with RL. So find their pattern, repeat their pattern with whatever given letters they're telling you to match up with. Same thing with here. It doesn't matter how complicated the picture gets, we're just following their established pattern. So they have AC over BD, so we match up those two parts, and then they want to take CE and match it up with, if we do the same thing, would have to be DF. So these fill in the blank problems should be fairly straightforward. It's just a matter of matching up which pieces did they use and what pieces do I need to match up with to get that same idea. So in the second example, CE matches up with IE, and sometimes these little markings can help you. So CE goes to IE, so what would have to go to HI to get that same exact setup? And so in this case, we see would be AC. Or if we look at some of the others, we've got GH going to GE. So GH is this piece right here going to the entire figure GE, versus on the other side going to GF, and that would match up with GB. Okay, so it's just what's their pattern and apply their pattern. HI goes to what if BD goes to DF? So BD, DF means HI to IE. Okay, so be able to match up corresponding parts using those theorems as well. It's a top to bottom, or left to right type of deal. It's just a matter of what is their particular pattern, and then apply that pattern. With that, you should be able to complete today's assignment. So make sure you get that in class or print it off of Google Classroom. Ask questions in class, email questions if you have them, check the answer key when it becomes available to make sure that what you're doing on the assignment is correct. And then make sure that you have that done ready to turn in when we ask for that in class.